In this video, we're going to look at cubic sequences. Cubic sequence is any sequence that has an n cubed in the general term. So n cubed plus 3n squared minus 7n minus 5, or n cubed minus 17n plus 2, or 3n cubed plus 32n squared minus 182. All of these have n cubes in, so they are all cubic sequences. And when we're trying to find a cubic sequence from a sequence, like the general term from a sequence, we have to look at the differences of the terms. If you haven't watched the quadratic sequences video, then I suggest you watch it before we progress with this. The method is very similar, but we need to take it one step further. If you're not sure about quadratic sequences, you're a bit rusty, you should also go have a look at that video first before we move on to look at these. Okay, so let's have a look. We're going to consider the general cubic sequence, which is un equals a times n cubed plus b times n squared plus c times n plus d. And much like we did with the quadratic sequences, we're going to look what happens for values of n for the general one. So we're going to have un. When n is equal to 1, we get a plus b times 1 is b, plus c times 1 is c, plus d times 1 is d. That's when n is 1. When n is 2, we get a times 2 cubed. So we get 8a plus b times 2 squared, so plus 4b, plus c times 2, so 2c plus d. That's when n is 2. When n is 3, we get a times 3 cubed, so that's 27a plus b times 3 squared, so that's 9b, plus c times 3, so that's 3c plus d. That's when n was 3. And when n is 4, we're going to stop there because we're going to run out of space otherwise, we get a times 4 cubed, that's 64a, plus 16b plus 4c plus d. That's when n is 4. Ideally, we need to go one further along to get to 5 so we can see what happens at 2 stages in the last section. But this will give us enough of a view. On the next screen, I have it with 5 typed out ready so you can see it. It's a bit smaller, so it's a bit harder to see, but it is there. So now we're going to consider the differences and the differences of these. So we're going to look at difference 1 first. So from a to 8a, we've got 7a's. From b to 4b, we've got plus 3b's. And from c to 2c, we've got a c. From 8a to 27a, we've got 19a's. From 4b to 9b, we've got plus 5b's. And from 2c to 3c, we've got a plus c. From 27a to 64a, we've got 37a's. And then from 9b to 16b, we've got 7b's. And then 3c to 4c, we've got a c. Now we consider the second differences. So the differences of the differences. From 7a to 19a, we have 12a. 3b to 5b, we have plus 2b. And the c's cancel out. From 19a to 37a, we have 18a's and then 2b's. And finally, the third differences, we have 12a to 8a is 6a, and the b's cancel. And this time rather than getting the 2a that we got for quadratic sequences, we get this 6a at the end that always works. And we're going to use that, and that to find the general term for a cubic sequence. So let's have a look at an example. Okay. So at the top of the screen we've got what we just did, but it goes up to the 5, and you can see that we get 6a appearing twice along the bottom in the third differences, as we would expect. And below that we've got a sequence -6, -4, 10, 42, 98 and 184. So let's start off by finding the differences. It's 2, then 14, then 32, 56 and 86. The second differences are 12, 18, 24 and 30, and the third differences are 6, 6 and 6. So now we compare 6a with 6. So we get 6a is equal to 6, which tells us that a is equal to 1. Now we compare 12a plus 2b with 12. So we get 12a plus 2b equals 12. We know a is 1, so we have 12 plus 2b is equal to 12, which tells us that b is equal to 0. We keep going. We have 7a plus 3b plus c and 2 in the next ones. So 7a plus 3b plus c is equal to 2. So 7a is 7 plus 0 plus c is equal to 2, gives us c is equal to -5. And finally, a plus b plus c plus d and -6. When we compare those, we get a plus b plus c plus d is equal to -6. That gives us 1 plus 0 minus 5 plus d is equal to -6, which implies that d is equal to -2. Finally, we can put this all together by using a, b, c and d to get un is equal to, well, a is 1, so we have an n cubed, b is 0, so there are no n squares, c is -5n, and d is -2. So our cubic general term for this sequence is n cubed minus 5n minus 2. Now let's have a look at a second example. Once again, we've got the general grid above, and then the sequence we're going to look at slightly below. 17, 59, 143, 287, 509 and 827. Let's start off by finding the differences. So first differences are 42, 84, 144, 222 and 318. The second differences are 42, 60, 78 and 96, and the third differences are 18, 18 and 18. The third differences are all equal, so we are indeed dealing with a cubic sequence, which is handy. So now 6a and 18. So 6a equals 18. This gives us that a is equal to 3. we have 12a plus 2b is equal to 42. So 12a plus 2b equals 42. But a is 3, so we get 36 plus 2b is equal to 42, which gives us b is equal to 3. Now we go for 7a plus 3b plus c is equal to 42. So we write in 7a plus 3b plus c is equal to 42. 7a is 21, 3b is 9, plus c gives us 42. So 30 plus c is 42, so c is equal to 12. And finally, a plus b plus c plus d and 17. So we get a plus b plus c plus d is equal to 17. A is 3, b is 3, c is 12, plus d equals 17. Gives us 6 plus 12 is 18, so d must be equal to minus 1. And then finally, we take the a, b, c and d values, and we get un equals, well, a is 3, so we have 3n cubed, b is 3, so we have 3n squared, c is 12, so we have plus 12n, and finally d is minus 1. So this method is just an extension of the one for finding quadratic sequences. We need the cubic table up here, but we only need the first 3 parts of it. Sorry, the first 4 parts of it, of each row. We don't need all of it. We need those 4 parts there to compare. And we compare those with the 4 parts from the table of the cubic sequence. You can either remember those 4 parts or quickly generate the table like we did at the beginning of the video when you need it. This method can be extended further for power of 4 sequences and so on by generating the sequence, the general sequence, and comparing it to specific examples. And in the next video we're going to look at the alternative method that we looked at for quadratic sequences in terms of cubic sequences. It is not quite as nice for cubic sequences because there's an extra step that we have to put in, but it is a different method that you can use to find the general term for a cubic sequence.